Okay, we're broadcasting live. So the purpose of this video is to walk you through thingsSDK, what it is, the current state of it, and where people can help. So on the line, I've got Joseph and Sam, who is free to ask questions at any point, to ask clarifications about anything that I skip over, because I'm sure I will. So the idea behind thingsSDK is to make it easier for professional JavaScript developers to work with microcontrollers that have JavaScript natively running on them. Normally, JavaScript developers have been using something called Johnny 5 that runs on their laptop or a Raspberry Pi, basically anything that's like a computer, and then can talk via USB or over Wi-Fi to control microcontrollers. That has some special software called firmware, called Formatter, installed on it. So that's that's what it is. Maybe I was clicking on Joseph, so Joseph is nodding while I'm talking. So maybe that was on the big screen. So Formatter is a protocol. It's MIDI-like for commanding electronics. Is that a fair explanation, Sam?
Yeah, that's a fair explanation.
So this is beyond. This isn't that. This isn't what thingsSDK is dealing with. This is dealing with JavaScript actually running on microcontrollers. So traditionally, you would have had to buy a Pico or an Espruino Pico or an Espruino board, and you'd have to solder on this little. It's a bit hard to see with my quality of my camera. Let's see if I can bump up the. Maybe I put it on lower quality when I was on a video call the other day. Here we go. There we go. So as you can see at the top here, there's another like circuit board. This is called an ESP8266. The reason why I know it's called the ESP8266 is because that's the board that you always use for these wireless things. So you had to solder it on. But on this board here, there's a microchip that is flashable, so you can install software to it, and you can install a JavaScript runtime to it. Before, you had to go through a long process of finding the right version of Python, finding the right binaries, putting them in the right directory, executing a huge command, and then JavaScript is installed on the device. Now, with thingsSDK, we've launched a cross-platform, so it works on Windows, Mac, and Linux. A JavaScript installer, so it installs it straight to your device, one-click install. It's a breeze. So that's the first problem we needed to solve. Then the next problem we needed to solve was actually using modern JavaScript. So if you use Visual Studio Code or Atom or Vim or Emacs, I love it modern, but if you use those things, you can use the tools that you're used to. I think the big failures with React and other web technologies is that they didn't have like a CLI initially to create an opinionated startup for a project, and we've seen that improve recently. So I've decided to create one for modern JavaScript projects. So instead of telling people, oh, you need this and this and this and this, all that and this and this and this is installed for you, and there's a little Hello World script for you to get going. So let's take you through a brief tour of what that looks like, or what the tool will look like, and all the components of that tool. So I'm going to start sharing my screen. Let's create a new command terminal, CMD, CD projects, and then can I screen share? Yes, I can. Screen share. I think this is the one, maybe. Yeah, that looks like the one. Let's share. Okay, so here's my projects directory. dir. These are all the projects that I'm working on. Some secret, some not. You can install the package globally right now, you can use GitHub to install thingsSDK CLI and -G. So this will install it globally on your machine. And I think I've already got it installed. So thingsSDK. And then you type new, and then the project. So project name. So let's call this demo. Hopefully I've got it installed. Yes, I do. So cd demo, and then npm install. And hopefully it will install. So this installs a couple of dependencies from thingsSDK.
Hey Andrew, what version of Node is this working with? Is it 4 up or 5 up?
I would say 4 up. I haven't tested it on these other versions of Node yet. I'm on 6 right now, so
Okay.
I'm using ECMAScript 6 syntax. So
Awesome.
I figured anything that can support it will run it.
Great.
Yeah, let's go to major releases, right?
Right.
So when it installs, it installs a script that you can run npm run push, and that will push code to the device. So as you can see, there's a Babel runtime here that's been installed. Taking its time. That's the thing with these dependencies. There's a lot. Cool. So yeah, it'll install the native module serial port because it talks over serial to your device. Don't worry about the red lines; it still works. This is the problem is that we're relying on a third-party dependency that needs tidying up a little, but it works right now. So
is that the that's the Node pre-jip stuff on Windows, right? That stuff can be, that's a pain. I think you have to have the Visual Studio C++ extensions and stuff like that.
Yeah, there's a whole level of pain there. Let me share you my Visual Studio code. I tried using that OBS software, but I couldn't get it working with Hangouts on the air. I could do it to YouTube, but I wouldn't be able to have any live feedback. So,
that program that Suze uses?
Yeah, exactly. So can you see my code, Visual Studio code?
Yeah.
Cool. So right now it creates a main.js. It says hello world to the console. Probably we want to have a blinking example as the hello world, but that's what it does right now. It creates a package.json for you with 2 dev dependencies, and that's thingsSDK deployer and then a strategy. So I don't know if any of you have used Passport before, which is an OAuth framework. It's really handy. They employ strategies to implement OAuth. So I borrowed from that terminology for strategies to upload to a particular JavaScript runtime. Espruino is one. There's also Canoma.js. There's also Smart.js or Mongoose IoT. So eventually would be able to have a single project and have these different deployment strategies if you were going to deploy to different microcontrollers running different runtimes. So that's that. So the push code looks like this. So it requires the deployer, and then it imports the strategy, and then it gets the IoT package.json. So that's this one here that's been generated. I've got the current version of Espruino in here. I think having versioning for the engines that it supports is super important because 1.8.5 removed the graphics library but then reintroduced it in 1.8.6. So this will become vital for validating packages that get installed via npm. So this package, IoT package.json, basically all your dependencies that will be in your project will be just regular dependencies, right? So maybe it's like some LED matrix thing, LED matrix, you know, whatever npm packages that would get deployed to the device itself would be there. But dev dependencies would be, you know, the deployer and maybe a test framework like Mocha or something like that. And it runs this push script that opens up the package.json, and it looks at this main file. So if you look here, it uses the main file. So the build strategy returns a closure that will build the code and then upload it to the devices. So there isn't a devices.json file that's generated. That's one of the issues that I've created to do a package a devices.json. So if we take a look at don't save this, is still sharing Visual Studio with you?
Yeah.
Yeah, cool. So this is my Wi-Fi gotcha. I ported it over to the thingsSDK version of things. So what these actually do is this employs an npm package called Rollup. Rollup is similar to Webpack, but it does this thing called tree shaking. Let me just show you what that looks like. Rollup. I'll share my screen in a sec. Node.js. I can. Setting. Nope. Rollup.js. Here we go. So Rollup.js is a modern way of packaging your code. So here we have Rollup and how it will export JavaScript. So if you include square here, square x, it will include it in the code over here. So if you don't use cube and say you use square and square here, see it only exports in the deployed code the function that you use, which is super important for IoT devices, because you don't want to package up the full module and then push it into the device. You only want to use the functions that you actually require or need for your application to run. So this is, instead of doing code analysis and removing dead code that way, because you're requiring it using this ES6 syntax, it knows quite easily what to include and what not to include in the packaged JSON. Now, apparently this is going to be this tree shaking, quote-unquote, style of reducing code is going to be in Webpack 2, so maybe we'll move over to that eventually. But that's why we picked Rollup.js for bundling code together. So,
cool.
the Espruino strategy uses Rollup and then pushes it across. I chose to do it at the level of Espruino's strategy because Canoma.js has implemented 100% of all the ECMAScript 6 syntax. So you don't necessarily have to perform that kind of transformation on that code. But we may need to do that to just get rid of code rather than deploying the full thing. So it's going to be nuanced on each microcontroller. So whatever strategy you do, you need that fine-grained control. So let me share my screen again. So yeah, this is what a project looks like. It has a version number. It sets as a private initially, and it should be theoretically you can use rollup with npm modules. I think you've just got to say JS next in your package.json for it to scan it in that tree shaking way, basically, and that's where everything's going towards anyway. So yeah, in my main.js, I just import the things. I've started creating this Wi-Fi manager where you can put in various different SSIDs, because normally you only have one SSID and you manually set it. Eventually, I want to be able to configure this, using a web browser. But right now, you can put in as many SSIDs. It searches for the things, and then it finds the one that it's got in its list of connections, and then connects to the Wi-Fi hotspots. So my iPhone 6 has a very secure password, something like a CEO of a big billion-dollar company would have. Actually, I think this is slightly more secure. It's got 2 more characters. So when it connects to my iPhone 6, it will call this method request, and then there's a callback called set face state, which will set the state of the face, and which will be either one of 3 things: neutral, happy, or sad. So if you take a look at the request, so that's in API request. I'm exporting a request. The Esprina has built-in modules. So if you use the require syntax, it will look for the modules that are built on the device itself. So there's an HTTP library on there, and in the Wi-Fi manager here, you'll see I'm requiring Wi-Fi. So that's kind of nice, because then Rollup doesn't include any of that or tries to resolve that, because it's not in the ECMAScript 6 syntax, and it just runs on the device, and just by chance it just works beautifully. So that's great. Yeah, if you look in the request file, it just does a HTTP GET, and it reads the data and then updates the state of the face in this callback. And it does that every 1 second in this particular application. It can use WebSockets, but I haven't implemented it in this API. It was a rough API. So this is what a devices.json looks like. You can replace that with your comport. So if you're on Linux or Mac, you'd be something like dev tty/ whatever it is. On Windows, it's COM7. The baud rate, that's the official, not the official baud rate. This is the baud rate that ESP8266 talk at. And Esprina board talks at 9600. The runtime is important, because then you know which strategy to use when deploying it to the board. So, and I didn't do an array, I just did it keys, because that's the trend that people are going for with JSON objects like this, right? So I am following that trend. So let's have a look in the thingsSDK build. So the build, what this does is it has an entry, but it returns a closure with a callback done. And what it does is the entry point is that main.js. It bundles it up using a plugin system, and then the bundle comes through, and it has code. And that gets sent to done, which eventually is used by this upload function. So the upload function just scans for the Esprina runtime. It filters all the ports for the Esprina, and then it just copies the key to the actual object, so that I can just do device.port at baud rate, set up this configuration, and then it flashes it to the board. Well, not flashes it, it just uploads it to the board over serial. And yeah, so that's all the strategy does, is it builds and uploads. And then the builder, the deployer, is just a simple, it runs a build, and then it runs an upload. And it does it in the build function once it's complete. Ideally, I think I want to make it more like middleware, so maybe all methods get the same runtime, maybe devices and code, but it gets manipulated as it goes through the middleware. But this was the first stab at the API, as it were. So the deployer is a constructor, is a runtimes, and it adds, I guess, the upload middleware to the runtime so it can be used later on here. And therefore it can store as many runtimes in one deployer, basically. Yeah, so I'm going to show you how it pushes it to the device.
So is this a replacement for Flasher.js, or is this after you've already flashed it with the Espruino runtime?
Yeah, exactly. So it's after right now.
Oh, okay.
So you flash the device with the JavaScript runtime. I think eventually, because you can query the board to get the version numbers, I think we're gonna need to export the core of Flasher.js anyway, because we want to give back to Espruino's IDE, because I think the Espruino IDE is great for beginners and just playing around. But like for a professional JavaScript developer beginning this type of thing, they want to use these modern tools. Like, say for example, you can't develop in multiple files, so it's super difficult.
Right.
So you have to spawn up an instance of a web server because it can go to remote files, but it's super gnarly to do it that way. So, let me show you in action. I think this is the right command prompt, sure. So let's go to cd Wi-Fi gotcha, and then npm run push. So this is building. It's done the tree shaking. All this output is from the Espruino's command line utility. We should contribute back to this to make this a little bit quieter. But once it's uploaded, I can show you what it looks like on the device. So I'll stop sharing. So before it connects to the internet, it's got this face. I'm sure people are familiar with this. And let me check if it's connected to my phone, which is always fun. It's always temperamental. Yes, it's connected. So I think this should start showing, hopefully. Let me push the code again. It's not that fault tolerant right now. Oh, there it is. It's there. Anyway, there it is.
There it goes.
Yay! I shouldn't have panicked. But there you go. There it is. It's on a Heroku instance right now, so maybe the dyno was spinning up. So there's my code being uploaded again, and there it is. So the dyno is up and running now, so it's almost instant. So if you go to wifigotcha.com, you can the face and it'll change. So it's like a massively multiplayer online Tamagotchi with 3 buttons. So this was my proof of concept that I can write in modern JavaScript code and it will be sad. Or happy.
I did it.
Yay. Meh. So that's the current state of the project. So let me go through GitHub with all the issues, because that's probably a good place to start. Ask any questions again if you need. So let's go to thingsSDK.
So that's a heck of a lot easier than when you had to write the binary code to get that screen to work, huh?
yeah. I mean, I can package that up now and distribute it really easily, right?
Yeah.
And the great thing is like it's not this massive library. Like if you're just drawing lines, it'll just export the draw line functions. It won't install draw rectangle and draw bitmap and all those other ones.
Right.
So let me share the screen again. Or is it? Oh, let's just use this Google Chrome one again. Sure. Okay. So github.com thingsSDK. So there's the CLI, and I've created 3 issues in here right now. So right now, basically, if you run the same command again, it will rewrite the files, which is pretty crap. But here I've mapped the link to do. It's always false, so it'll always it will always do this, which is it'll rewrite the files. So it needs some sort of like read line thing there to like. I think it would be nice to say, yeah, I don't want to overwrite my main.js, but I want to overwrite the package.json and maybe the build scripts. Maybe if there's a new version of these deploy packages, that may be nice to just nix those things, but just keep your main.js. So I think that's probably the best feature for that there. A new project should have a git ignore file. I think this is a really quick and easy win to implement for somebody. So right now, if you look in this templates directory, we have a main.js file, which gets copied over to the root of the folder, and then for the Espruino runtime, it just copies this into their scripts directory, the push strategy. And the great thing is like it's not too difficult. You could have your own middleware implemented here if you wanted to add another step. You know, like if you wanted to include TypeScript or CoffeeScript, you know, you could do that if you wanted to. But we're just giving you sensible defaults, right? And then generate a devices. So that new command defaultly includes a runtime Espruino. So eventually we may have different runtimes that you can pass in as arguments when you say create new, you know, thingsSDK new project name -- runtime blah, you know. So right now it's just Espruino, so you can access that in order to just add this in here. So maybe because it's the Espruino runtime, we know that the 2 main baud rates are these 2. So it should scan for serial ports. Well, it should ask the user to enter in, you know, plug in their device, and then pick which port it is, set the baud rate. Maybe the default is this number, and they just hit enter, so they don't have to press 1 or 2. Or they can enter in, you know when you create a package.json file, and it has defaults in there, and you just can hit enter or replace it. I think that's the kind of interface that I'm imagining for at least this step here. And it creates a devices.json file that looks like this and should be added in the git ignore file. Because if you're working on it on a Windows PC and then someone else is working it, even on a different Windows PC, the COM port could be different, right? So the idea is that you don't check in your devices.json, so basically we needed actually devices. Yeah, when you create a new project, maybe that hooks into a devices command. That because maybe in a directory you want to just say thingsSDK devices and it generates a device. So I think I actually say that in this thing here. Yeah, so like thingsSDK devices, or find devices, or create JSON, or I don't know, devices I've put for now. So maybe there's a nice command like that the new command runs straight afterwards, and a user can run it manually to add more devices to the packet to the devices.json. So that's the command line CLI. There's at least 3 tasks there. Some of them are really quick wins. I could easily do them, but I'd love for people to just try it out. Then in the strategy one, errors during code. Right now it silently errors. I think with this done function doesn't do anything. I don't know where this in the deployer gets called back to, but it doesn't look like the error gets passed through or spat out. It just needs to show, oh, by the way, on this line you forgot this, you know. or can't find this file. Because like when you import via the import syntax, it doesn't defaultly open the index.json like it does with the require syntax. You've got to say like display/index or whatnot. So this is the it may actually end up being something in the deployer that will handle it. In this callback here, for some reason this error, maybe this throw doesn't console log anything, or it higher up in the chain. So maybe this is probably the best part to catch that code. So let me just add a link in that other issue in the strategy. I can do that later. I'm not signed in on Chrome. I don't know. I'm not normally in on Chrome. So those are the three main packages: CLI, the deployer, and the strategy. And I've included issues on all of them. So feel free. Is there anything that anyone wants to take a stab at? If you do, just we can talk about it now, so you're not treading on anyone's toes, or you can just say the first person to write a comment saying, "Hey, I'll take this one on," and then I'll assign you to it. How does that sound?
Yeah, that sounds good.
Pretty good, yeah.
Any questions about it all?
No, it seems. I mean, it seems pretty straightforward. I'll just definitely gonna like look through the code and follow it.
I started creating a test directory in Mocha tests so that we can start actually testing this code. But this has been. Why are you shaking your head? That there isn't tests there in a JavaScript project, or that I'm wanting to do tests.
Both, I guess.
Yeah. But yeah, I just wanted to get a proof of concept working, and I think I've got the right separation of concerns in the modules. I didn't want to go too like, hey, there's a module for everything. There's the main CLI and other things. Let me just show you one thing in the CLI code real quick, because I think having this tool will probably help you get bearings quicker. So in the CLI, there's this bin folder, and then there's commands. So there's this new command, and it basically defaultly sets the runtime. Basically, it uses yargs for I think it's called yargs. Yeah, yargs, and it requires at least one new command. This is one of the commands. A lot of this function code could be taken out of this refactored out instead of just being in this main bin folder, into maybe file utilities or something like that, because I've got like create files and copy files, write files. Here's the package.json that I create. So the app name sets the default app name here. So like, no matter what path you create, the last folder is the default name for the project. Excuse me. Creates a main.js, package.json, and currently it's using the GitHub modules, the master branch. So if you ever needed to, fork it to your own GitHub, you can put in your usernames here to deploy your version of those to test. And then it adds the engines key of the runtime with the runtime value of the current version of the runtime, which is up here. Yeah, so this only has two dependencies as well, which is the make directory thing and the yargs. And I guess it needs a dev dependency for Mocha as well. So yeah, most of the code is in this bin folder here. and this command was just for a quick and easy. Oh, you exports this for this, you exports this for this, and you exports this for this. You know, it was in the documentation, and it seemed the most elegant way for something if you're going to create multiple commands in the future, like devices, you know, to include down here. So this, I think, demands at least one command. So you could put underneath here .syntax and have commands devices and things like that. Cool. So there you have it.
Neat.
Yep. Thanks again for spending your time on a Thursday evening with me and fellow JavaScript enthusiasts. I am really excited about this project. I think it's what's been missing, and this will help us tap into another group of people who want to build embedded systems with JavaScript actually running on it on a low-powered microcontroller that is cheap. You know, these microcontrollers are like $3 a pop. You know, it's crazy. I think that in terms of you know, having this accessible to a wide group of people, and it also makes it so that the Zuckerbergs just like, hey, I can code everything in my house, and I'm going to release this closed source thing, or I don't know, this thing that will snoop on you, when we can take back the power ourselves and code these things directly in a really simple way if we wanted to.
Yeah.
Cool.
Awesome.
Any other questions?
Well, so maybe it's helpful, just for me at least, to recap. So the problem we're solving is like, okay, we could run JavaScript on like on your laptop or like some intermediary computer, and then like that thing would translate commands and send them to your microcontroller.
Yeah.
It understood. But wouldn't it be better if the microcontroller we wanted to use just understood JavaScript, just had a JavaScript runtime on it? Okay, so we solved that with Flash.js. Put Node on your thing or whatever.
Yeah.
And then there's still
runtime, yeah.
And then there's still the question of like, okay, now it itself understands JavaScript, but I want to be able to deploy JavaScript to that environment. I want to be able to write it in the way that I'm used to writing it on the web.
Yeah.
And this library is a way of enabling you to like break out your files and then just like be able to run commands that will like bundle that all up and send it over in a trustworthy way.
Yeah. Yeah, it's not on a third-party service. You know, it's not in the cloud. It's not. You literally can look at the code that does it and modify it if you wanted to. But no, basically, as a professional developer, you don't want your IP in the cloud on someone else's like platform, you know, or this, that, and the other. You know, you want to actually have that IP and property and code on your device, and also you want it in a modern way and an easy way, an opinionated, let's get you started way, right? That all those things. And that's all those things that I hope that this is doing. It feels like it when I'm doing these test projects on it. So, like, you know, I've got, like, hundreds of screens in all different shapes and formats. You know, I've got Feather Huzzahs with OLED screens. So I can start building these libraries. So, like, you could buy something off Adafruit and just import Adafruit OLED wing, and it'll run. You know, without you bit twizzling. I can do the bit twizzling for you and on your behalf. You don't need to learn binary. You can have a very simple syntax, you know, and import modules like you used to in multiple files, compartmentalized, testable code. That's what I want for IoT, because you know, C is one of those languages that is ubiquitous and is, you know, it's there for desktop, it's there for mobile, it's there for embedded systems. JavaScript hasn't really touched it until recently. And if the tools aren't there, no one's working to solve this problem. We are. This is it. This is it. And I believe that if we're the ones who are going to do it, we're going to do it well because we're modern JavaScript developers and we're interested in this stuff and want to get it going. And we know what tools we like. The ones with CLIs that create the things for you, that are opinionated, that you don't have to go through all this setup. You know, it uses package.json rather than this whole massive build system. You know, it's what you're used to. So yeah, riffing on that problem-solving thing, yeah, it's that and all those other things.
So, what about like, say you set up a breadboard with a circuit and that kind of thing. How are you then able to write JavaScript to control, like to basically replace Fermata and say, like, blink this pin on this, I mean, the LED on this pin, like, are there already ported libraries for that, or do we need to write those?
We need to write a lot of this. A lot of this stuff is built into the runtime. So maybe not everyone's familiar, but like a JavaScript runtime has native objects, which is like arrays, strings, numbers, booleans, things like that. Then it has host methods and functions and objects. So in the browser, you've got the DOM, the document object module, to manipulate an interface with the DOM. On the server side, you've got Node.js, which has HTTP and event handling and stuff like that. On Esprino, there's actually every object is an event emitter, which is kind of nice.
Oh.
Yeah, it's got digital write, and you know, so like the commands that you would call in Arduino have actually been ported. So like very similar commands like digital write to this pin, high low, or 1-0, or true false. It doesn't matter as long as it's a truthy or a falsy thing, and it'll switch the thing on and off. So once it's written on the board, it's on the board. The JavaScript's on there. You can plug it. You can plug it elsewhere. You know, it's detached from your computer forever.
Right, right. So you could basically just write the same kind of, well, I mean not the same, but a similar sketch of like reading temperature sensor data and have it send it wirelessly over, similar to how you would with Johnny 5 or with you know, firmware, do the same thing.
So like, let me show you this what I was working on last night. I only got so far with it though. So Lausanne is an IoT platform which enables you to build workflows with devices. So you can have one device here, it talks to the cloud can send messages to your phone or to other devices. So like maybe you want to create a security system for your house. You press a button next to your bed and then it arms all the devices around your house. So it takes away you creating this server entity, but has a drag and drop interface to do certain things. So Lausanne gave away some kits. They also sell kits for temperature sensors and things like that. And this is the one that they gave you with a Feather Huzzah, this board here from Adafruit. And I started writing the JavaScript code in this format to try and get this going. So let me show you where I got up to last night. So basically, every 15 seconds, it grabs the temperature, which is an object that has a Celsius and a Fahrenheit. And yeah, so that's all it does, is it gets the average of temperatures over 15 seconds or 1 second, and it averages it, because these cheaper temperature sensors are only so good. So getting a nice average over a long period of time gives you a kind of more accurate sense of what's happening in the environment. So I just created this simple temperature sensor function here. You know, it goes every so many seconds, the read handler will get executed and sends this out. and I just use set interval rather than these loops. In C, all of this code is basically loops and blocking, whereas in JavaScript everything's event driven, and it will just kick in when it needs to next, and it'll kick in when it needs to next. And anecdotally, Kinoma.js, created an e-reader in Japan that was written in C, and then it was written in JavaScript in America. The one in JavaScript was much more responsive. And it's not that you can't write non-blocking code in C, it's just that C developers aren't used to it. JavaScript developers, it's like water off a duck's back. It's just it's a breeze. Once you've got over that cognitive first overload of like, oh, my code can run anytime, an event happens. Oh, wow, that is really cool. That is really cool. And that's what's really cool about hardware is that's the exact kind of features you want in a language for saving power, not using clock cycles, and doing all that stuff. So yeah, that's what I did last night, and I got the temperature running in this thing. So maybe I would change the API differently, but I was just getting it up and running and trying it out, and so far it's working. And
nice.
In an evening with a sensor, you could write a library for it, basically, which is not bad if there's multiple people doing it, and believe in that same, hey, let's just push JavaScript to the device. You can actually have a server listening on this so you can push code to it remotely as well. So
cool.
You can push your JavaScript code. So maybe the CLI, so where it says com, maybe that'll be an IP address, and it'll know the IP address and it'll push it, to that instead in the devices JSON. So literally you could deploy things all around your house if you really wanted to. And you can actually flash firmware on these devices using Post.
Oh, wow.
So Flasher.js probably needs that integrating eventually as well. So literally, this is the beginning. These are the problems that we're solving. And yeah.
It seems like for those sensors and stuff, you could borrow a lot of information from Johnny 5.
Yeah.
They've kind of hashed out a lot of that work. It's just that they're translating it down to Fermata. But I mean, all of the specs, like if you go through those sensor files in Johnny 5, they go through a lot of that stuff.
Yeah. The unfortunate thing about that is it's all in their in ECMAScript 5-ishness, and
oh, right.
you can't tree shake it effectively.
Yeah. Well, maybe at the very least, maybe it's a good resource for getting.
Yeah. Like I was looking in it last night for that AREF, but then I ended up translating the Arduino code from the Lausanne workshop.
Yeah.
And that was blocking, and then I just changed it to unblocking. Set timeout code. So that's why there was like, oh, this variable and this count. It probably could be streamlined a little.
Right.
Using reactive functional programming.
Of course.
So Espruino. So this is so Espruino is a JavaScript runtime environment like Node, and it has its own this is what I heard you saying earlier. Just like the browser environment has the access to the DOM APIs, and Node has access to the process APIs and the file system. Espruino has access to the pin APIs and everything.
Exactly, the pin, the Wi-Fi, low-level network stuff. That just literally anything that the board can do, it can do. And some of those APIs are exposed in a Arduino-like syntax, and the function, pin up, or pin mode, set it to input output. And also it borrows from the Node API with the HTTP server. So it's not Node's HTTP server on there. It's an implementation of some of the APIs of the HTTP server for Node.
So the project of writing all these all these modules for particular sensors is in some sense just like the project of wrapping up some of these APIs in like more usable functions.
Exactly, yeah. So I think what you could eventually do is like maybe this sensor is called the TM39. Maybe the package is TM39 thingsSDK or things TM39, and we could have shared functionality like the calculations of getting the input, the analog input. You need to multiply by constants basically to get it to be Fahrenheit and Celsius. Now that can be shared across all platforms, whereas the specific APIs for each of the JavaScript runtimes could be just one function. So you could say import from TM39 / Esprino / Kinoma / this, and because those other functions are separate in a different file, and maybe you only want the Celsius, so it will include the Fahrenheit code. You know, and things like that basically will be able to make these sensors work in a lot more settings, and maybe there'll be an adapter for Raspberry Pi and Linux-based Node instances eventually. And then it will be truly universal JavaScript, right? That can run on microcontrollers and computers, right? And any browser interface, like if you were to mock out these things in a UI, so you could code and practice it in a browser, you could do that too, right? That code can run anywhere.
Cool.
So that's me riffing on the idea. I think it can have all these legs given enough time and dedication to it, and getting this into as many hands as possible, because at the last JavaScript and the Internet of Things meetup, Roberto was saying how, you know, he works for Code for Nature, and it's his company, and he wants to distribute all these devices in a woodland so that it can be interactive. But he's also got friends who are professors who are saying, yeah, we want cheap devices, and it's got to be easy to use. And unfortunately, it's not that easy to use right now. There isn't any. I mean, there's guides, and you have to write all the code in one file in this IDE that is good for beginners, but it's not necessarily good for professionals. But they said that they want it to be easy and cheap, and they only need approximate readings, and then they can go out and say, actually, we should look at that spot more in depth with higher fine materials. So they're making all these projections, these environmentalists, and they don't know how accurate they are. And deploying devices like this into wherever, you know, would make sense. Yeah. So, and I think deploying these devices with JavaScript on in loads of circumstances. You know, they could be used, you know, for early warning systems, for earthquakes, for crises, for anything, you know, distributed across vast distances and also locally, you know. So yeah, and it's just interesting that we just did the flasher and nothing else, and people are starting to use it in these ways. They just need more tools and more support, and I think that is where things are gonna go.
Cool.
I can't wait to see what people build. It's gonna be cool.
Yeah, it's exciting.
Yeah, sounds good.
Cool. So yeah, tag yourself on these make issues if you see them. Generate pull requests, and we'll start merging all this stuff together and making a mess.
Great.
Sweet. Yay.
Cool.
Of course.
I think I will download this video, edit out my passwords and IDs, and then re-upload the video.
Nice.
Right. Take care.
All right. Thanks, Andrew. Bye.